Okay, so let me write the main title, then we will discuss about this one. Okay, so the main title is importance of center of gravity. Okay, if I ask one simple question to get you ready to think about this question, is it important to know the center of gravity or not? Is it important to know the center of gravity?
Sorry, sir. Can you repeat your question once?
Yeah, this is the question that I have written here. Is it important to know the center of gravity or not? If it is important, so how can it help us to improve or to use it in our daily life? Center of gravity, or what is the effect of center of gravity in our daily life? Yesterday also I exactly gave you this title to get ready about this title for today. Ms. Zainab Nazari, you may continue.
Okay, teacher. I'm ready to answer your question about is it important to know the center of gravity. I think that yes, it's important because it helps us to understand, for example, how objects balance and move.
Yes, first it is very important that we should find center of gravity because it can help us to understand that in which point the object may stay in balanced situation and in which point or when the object may lose their balance. Thank you so much, it was great. Ms. Mursa Lamiri, may continue.
Yeah, I think that the center of gravity is important to know because it actually is crucial because it determines the stability, balance, and the movement of any objects or the body of a person.
Yes, now in the next slides we will explain why center of gravity is very important to understand. If we understand the center of gravity, then we can change the center of gravity, and that changes can make the object to be stable. Yeah, this is the main point. Yes, Ms. Nadir, you may continue.
Yes, sir. Actually, the main points were covered by my classmates. Why the center of, gravity is important because it teaches us about the stability and how to make balance between objects. And the one example that I can give from daily life is the construction in engineering, because like this balance, this center of gravity helps us to make really modern apartments and tall skyscrapers without falling down, because if we didn't know how to make them a stable balance, we wouldn't create these much tall buildings, and also even in other concepts of life, like buses and cars. They are all being made considering the center of the gravity, and many much more examples are available in daily life.
Yes, it your definition and your information is much greater than my expectation because the things that you explained, most of the points again will be explained in today's presentation. Your information is great. Okay, thank you so much for your information. Now see that most of, not only about the as Ms. Nadiri said that when we design a building and we make a building and when we construct a building, and in constructing or making a building, if we do not think about the center of gravity, so what will be the consequence of the construction? So without using the construction, the building may fall down. Why? Because we don't know where is the center of gravity, and if center of gravity come out of the base, so of course they will fall down. And the cars, for example, when the drivers drive very fast and when they are going to turn right or left, and if the center of gravity come out of the base, so they will fall down and we will have car accident. Actually, center of gravity usually protect our life against the natural or environmental accident, event, or anything else. So yes, this is the important point, and today inshallah we will explain point by point together. Okay, now come to this slide. Yesterday I told you that what is center of gravity? What is center of gravity? Who can explain? Just the definition. What is center of gravity? What is center of gravity? Yesterday we talked about this, just the definition. Okay, short and briefly definition. Mursa Lamiri, we continue.
Yeah, a center of gravity is actually the points that where an object's weight is considered to be concentrated.
Okay, center of gravity is a point. For example, here, this is the point. Center of gravity is a point that this point consider the all weight of this object, all weight of this object concentrated or collected in this point. For example, if you think and if you take this roller and put your finger on your finger in this point, so you may think that this, you may see that this roller may not fell from the right or fell from the left, and they remain stable, balanced, and you think that the weight of all this roller may concentrated or collected or gathered in this point. So this is the definition of center of gravity. Okay, so center of gravity, the definition is again repeated here: the point through which the entire weight of an object appears to act. Okay, so here we have the rule: an object perfectly balanced when supported exactly at its center of gravity, because weight is appear only and all turning effects can cancel out. Okay, so it means that if you find the moment of this point with the moment of this point, so the total moment of anti-clockwise will be equal to the total moment of clockwise. Okay, so if you think each of them one point, one particle, and if we finally count the moment of all of them, so finally we will see what the moment of left side is equal to the moment of right side, or the moment of clockwise is equal to the moment of anti-clockwise. Yesterday we talked about how to find center of gravity. How to find center of gravity, this question. How to find center of gravity. Center of gravity. Okay, how to find center of gravity? Yesterday we classified the objects in many different parts. Okay, do you remember how many types of objects or shapes do we have? If we want to find the center of gravity, we should classify or divide our objects or shapes in many different classifications. First you should find. Yes, Ms. Nadir, you may continue.
Yes, sir. So actually, yesterday we have studied that, like how many types of shapes do we have. The first one was regular, and another one was irregular. For regular shapes, we would draw some lines from the edge of them. If like it is a triangle, we would draw some lines starting from their angles, and then the intersection of those lines would be the center of the gravity. And for irregular shapes, we would hang it on the wall, and then after that, draw some lines, and then again the intersection of those lines would be the center of gravity.
Yeah, thank you so much, Ms. Nadiri. Yeah, your definition was complete, but you defined or explained half of our classification. The half or the remaining part is we have one more part. Ms. Elaha, you may explain as you mentioned. Yes, Ms. Nahidu Marza, you may continue.
Okay, shapes. We have two kind of shapes. One is 3D and the second one is 2D. And 2D shapes are divided into regular and irregular shapes.
Yeah, that's okay. We have actually in the first part of the classification, we should classify the objects or the shapes in two parts. One is 2D, one is 3D. 3D means three dimension. That as we know that we have width, we have length, and we have height. Okay, in 3D dimension. So today we will talk about the importance of 3D dimension or 2D dimension or 3D dimension, three dimensions object. And yesterday we explained about 2D or two dimension objects. For two dimension objects, as you can see that here we have the shapes of one is rectangular and next one is triangle, and here we have, if we draw the lines from one side of the object to the another side, and the same if we draw another line, so the intersection of all these two lines can be the center of gravity. Center of gravity, it is here. Okay, so by drawing the line we can find it. These three shapes are regular, and we have irregular shapes. Irregular shapes means by hanging on the wall, as Ms. Nadiri explained, then by drawing the line, vertical line to the hanging on the wall, vertical line if you draw from many points, the intersection of all those lines are the center of gravity of an irregular object. Okay, now let's come to the 3D or three-dimension objects. When we talk about the importance of center of gravity, we should find the center of gravity of one 3D object or three-dimension object. Okay, so here we have one object and this object is 3D. How can we find the center of gravity of this object? How to find the center of gravity? We will not focus too much on the center of gravity in these types of object. Just we will discuss about the importance of this. So just let's find how to find the center of gravity of this object. Okay, do you have any idea about this one? Isn't it the same as 2D objects or 2D shapes? Okay, so let's find the center of gravity of this object. If you want to find the center of gravity of this object physically, for example, physically if you want to find, so here you should draw one line. Okay, one line from this corner and from the center of this object to this corner. Okay, for example, if we draw a line here, it is like this, and you should draw a line from this corner to this corner. Okay, so like this one. And next one, here we should draw this corner from back side of this object. Okay, but here it is 3D. By drawing line it's very difficult to find. First we should find the length of this object. For example, here, how much is the length? For example, if we have 100 centimeter, we should divide it over 2, 50. Okay, for example, 50 is here. And how much is the height of this object? For example, the height is 50. We should divide over 2, it is 25. Okay, from 50 we should move on to 25 centimeter up. So this is in the middle of this container, above 50 centimeter, above 25, and from the one side to another side 50 centimeter is equal to what? Center of gravity of this object. Okay, so in center of gravity, how many points are very important if you want to make one object very stable? As we explained, for example, center of gravity can help us to make one object stable. How? Do you remember how, or which points are very important in having a fixed or stable objects? Okay, no one? Okay, so I wanna make my question more clear for you by drawing two shapes. Okay, for example, if I draw two bottles here, okay, now if I ask you which one of these two bottles are stable, which one of these two bottles are stable? Stable, and why? Okay, now can you explain? This is my question. Okay, which one of these two bottles are stable and why? Yes, Miss Nauruzi, may continue.
Okay, sir. Sir, I think the first one is more stable because its base is wide.
One, because of the base. Why?
Yeah, and also I think the center of gravity should be low. Then the objects can be more stable.
Okay, if for example, if you find, for example, the center of gravity, the first point, as you mentioned, it is very important to have a wide base. The base of this one is wide. And next one, for example, the center of gravity of this one is in this point. Okay, and if we check with this one, the center of gravity of this bottle is, for example, this point. Okay, so which one is very low center of gravity, has very low center of gravity? The first one. Okay, low center of gravity. Yes, the first point, for having a very stable object, we should have wide base, and next one we should have low center of gravity. Yes, of course, that these 2 points are very important. Okay, so now let's come to the next object. As you explained, for example, here, these 2 points are here. Okay, maximum stability requires 2 conditions, the 2 conditions that Ms. Nawrozi has explained. Okay, for example, a beautifully broad wide base. Okay, we should have very wide base. On that time we will have a very stable object, and then extremely low center of gravity. Low center of gravity also can help us to have a very fixed or stable object. Okay, so these two points are completely explained here. Okay, now see that these 2 bottles, the first one, which one of these 2 are very stable? As Ms. Nawrozi explained, the first one, number 1, is more stable. Why? Because we have wide base, and in here we have narrow base. Okay, so if we have wide base, it means that this object is unstable, object number 2. And this object is very stable because the base is very wide, extremely wide. And next one, we have 2 cars, car number 1 and this is car number 2. Which one of these 2 cars are very stable, very safe to drive? And who can explain? Yes, Ms. Nadiri, may continue.
Okay, sir. So in this photo, I think the first car is more stable, and the reason for my answer would be that it doesn't have much height. I mean, it is a low height, and also yes, the shape also could be important here.
Okay, one, the center of gravity is very low, and next one, yes, next point must be explained by Sarah Ibrahimi.
Sorry, sir. Actually, in my perspective, it was the same as Nodajan mentioned. The center of the gravity is lower, and it have the less risk of being fallen, and that's why the first one is stable.
Yes, the first one is stable. One reason that, as Ms. Fatima Nawrozi explained, Ms. Ilaha Nawrozi, sorry. As she explained that first, the center of gravity must be low. Yeah, the first object, the first car, the center of gravity is very low. And the second object, which is very important as well, for example, these 2 objects are having the same base, but the base of the first one, because the first object is very small, and for a small object and very wide base is very important. Okay, so that's why driving for the first car is very safe. We will not have any problem, and 99% there will be no car accident, even if you drive the fastest and the most carelessly way. Okay, but the first and the second object, if you drive fast, so you will face car accident or you will face dangerous situation, and the next one as well. Okay, so here we have some points, and these points are very important if you want to differentiate among the stable and unstable objects. Okay, so here we have stable, and here we have unstable. So how to differentiate? Here are the points. Center of gravity for a stable object. Center of gravity for a stable. For a stable, center of gravity are very what? Very low. But center of gravity for this types of for unstable objects are very high. So that's why. Next one is base width. Okay. For the base, if we consider these 2 objects, base of the stable system is very broad, wide. Okay, broad and wide. And for unstable object, this the base is very narrow. Not only about this one. So see that this object is very big. This is a big object, but this one is very small object. But the base is completely equal to each other. The base of this one is equal to the base of this object. Why these two are completely different? Because the object itself is very small in the first one, but the object itself is very big in the second picture. So that's why the first object is much safer than the second object. And reaction to the disturbance. Reaction to the disturbance. This is very important question. Returns to the center. Returns to the center. Easily tips over or falls over. Okay, so I want to explain this one in different slides because this part is very important. Okay, engineering application means shape decanters means that these types of bottles, if used like these types of bottles, they are very safe and they will not come out. And sports car like this one, and tall vases like this one, bottles, or for vase, that the object that you put your flower on, this one, okay, like this one. And double decker bus is this bus, okay. So the bus that which has 2 floors is called double deckers bus. And let's talk about this point, okay. Reaction to disturbance. This is very important point. I want to draw 2 objects, okay. For example, if we have this object, okay. So if I ask you this is object A and this is B, a simple question, which one of these 2 objects are stable?
Sir, I think the object B is more stable.
Object B is more stable. Okay, yes, this is exactly object B is more stable, yeah, as you can understand based on watching the picture. But if I ask you why?
May I answer?
Okay, all of you. I
sorry,
will give a chance for all of you to explain this one because this is the main point. And if you can differentiate between the stable and unstable physically, if you can explain, this is the main lesson of our today's object. Okay, Ms. Sarah Ibrahim, first you may continue.
Yes, sir. Because the center of velocity is lower than the object A, and that makes the lower risk that would be fallen, and that's why the B is stable more.
Yes, the first point, the first number 1, low center of gravity, next. Yes, Ms. Mursal Amiri, you may continue.
Yeah, I think that as my classmates say, that object B is more stable because it has low center of gravity. Also, it is broad.
Yes, broad base.
And it is wide base object.
Yeah, broad or wide base.
Narrow, it's high. Yeah, and A is not stable because it is narrow. Actually, it is too high, and it may fall over.
Okay, yes, this is the exact point that you mentioned. Now, for example, if I draw this object like this one, for example, if I bring this object like this, Okay, so if I bring this object to this situation, will this object come back to the first situation or not? So this is called interaction. After interacting like this one, will the object move back to the original position or not? Okay, who can explain?
Sir, actually there's a little possibility that the object should move back to the same position. Maybe it would be fall because mostly the objects that they are higher, they have the I can say they don't have the low center of gravity. Because of this, they would be kind of fall to the ground if they just have this kind of objective movement.
Yes, you're right completely, but here for example, if we want to count it, okay, based on the physics and based on the mathematics, and if we really count till which point the object may move back to the real position or the original position, till which point the object may not. For example, if you push this object till this point, so of course this object may move back to the original point, but till which point our object may come back to the original position? Yes, Ms. Nader, you may continue.
Yes, sir. So basically, there are, this is like a 50-50 chance. It may fall and it may not fall. But here, as I can see, it is supposed to fall because in this, if we, change it in this position, it doesn't seem like a balance, like a stable object. So therefore, it will fall. If that was a little bit closer to the original position, in that case it wouldn't fall. But since it seems like so unstable, so I think it will fall.
Yeah, this object, your definition in this object is completely right. But when you say that it is completely chance, it may come down or it may fall down or it may go back to the original position. But in physics, and especially in physics, we do not talk about what? About the chance. Okay, everything is based on formula. Now I can tell you that till which point the object may move back to the original position and till which point the object may not. Okay, so here, for example, you may center of gravity of this object is which point? Here is the center of gravity. Center of gravity. From center of gravity, you may draw a vertical line. A vertical line. Okay, so this is the vertical line from center of gravity. If this line was inside what? Inside the base area. Okay, inside the area of the base of the object, so the object may move back to the original position. But if this line came out of this area, so the object may move what? May fall down. Did you understand or not? I think I was not enough clear to explain this one. Okay, so I want to draw one more picture for you. Okay, for example, if we have this object, sorry, let me draw again. It was not Okay, so this is the main object. Okay, now I wanna draw something. For example, I wanna push this object. I want to change this one. Okay, for example, again, this is the main the base of this one, but I want to draw it like this one. Sorry, let me to make it a little bit clear. Okay, so this is the second position of your object. Now if I ask you this, the interrupted object, okay, interrupted object, will it come back to the first position or not? Interrupted shape. Okay, for example, you may think that this is the center of gravity of your shape. This is the center of gravity. Okay, so you may draw a vertical line from the center of gravity. Okay, now is it in the area of base or not? Okay, you may do check it. Will it come back or fall down? Just I need your confirmation.
Yes, sir. We think so.
Yeah, see that this object may move back to the original position because when we draw a vertical line from the center of gravity of this shape, still the line is inside what? Inside the area of what? The area of the base of this object. But if this line come out like this one, like this object, okay? If this line come out of the area of the center of gravity, so this object may not move back. It may fall down. So that's why when we talk about this one, okay, so these types of object here, see, these objects are stable. Why? Because if we, for example, force them, entrap them, again the center of gravity, if we draw a vertical line, they are in the area of the base of this object. But what about this one? And they are directly coming out of the center of the base or the base area of these objects. That's why in this part, in stable objects, reaction to disturbance means return to the center. But easily tips over means that easily they fall down. That's why if we have center of gravity in the center, low, and for example, if we have wide base, so in this situation, so the object will be very fixed and stable. Okay, any question, any problem till this point?